Now, in the last video, we've done the version 1 of the question, but version 1 is wrong because we've forgotten to take the weight of the word into account. Now we do version 2 now. So the free body diagram should look like this. So this, we've got the tension force. So this is a free body diagram. This is a tension. So this thing is a free body diagram. So version 2. Okay. Now we take moment about the hinge. Take moment about the hinge. So oh, the word hinge is no D in the word hinge. So the sum of anti-clockwise moment is equal to sum of the clockwise moment. Now this time the anti-clockwise moment is also the force T times the distance 2 times sine 40 degrees. But now the anti-clockwise moments, there should be one more term, which is what is it? Which is a 10 times 1. So the right hand side sums up to 90 times 1.2 plus 10, which is 118. So it is 118. So therefore the tension should be 11A divided by 2 times sine theta. So that, what is it? That is 59, isn't it? 59. So that's 59 times over sine 40. So 59 divided by sine 40. So it's 91.8. So it's 91.8. So to be more accurate, it's 91.7877. Okay, 1.8. Okay. Now with that, it can go to the next part of the question. So now in this part of the question, we've got to add one more force. So we add one more force, which is 10 newtons. So here we add one more force, add one more force, which is 10 newtons. So 10 newtons here. Okay, this is the new free body diagram. So this part, then we make it a little bit smaller. Now horizontally it's the same, okay, and vertically it's a bit different. Now the R sine theta is equal to the downward force, which is 100, the sum of the downward force, minus T sine 40 degrees. Okay, T sine 40 degrees. Oh, I beg your pardon. Is it 59? 59. What was that? 59 over tangent. So 59 divided by tangent 40 degrees. So it's 70.31346. All right, and this part so it's 100 minus t times sine 40 degrees, which is 59. So 90 minus 59, 90 minus 59. So it's 31. It's only 31 newtons. Because tension is larger. No, it's 100. 100 minus 51. It's 41. So it's 41. So the reaction here should be 70.31346. So what do we have? The square root of 70.31346 squared plus 41 squared, and we get 81.4 newtons. Alright, and the angle theta should be the y component. Divided by the x component. So the angle at which the reaction acts should be arctangent of 41 divided by 70.31346. So what do we get? 30.2 degrees. 30.2 degrees. Alright, so that's part B. So part C. So part C, we can use the same argument, but this time we've got to add the moment due to the weight. So that's a 10 times what? Times 1, isn't it? 10 times 1. Yeah, 10 times 1. So the previous argument still holds. So W is equal to this moment minus 10, the whole thing divided by D. So as the load is shifted to the left, the number D decreases. So for the same T, W can be larger. Okay, that ends the version 2 of this question.